In this chapter, we're going to spend our time analyzing quadratic functions.
Alright, hi everybody. So in this lesson we're going to take a look at the characteristics of quadratic functions, like the title says. But what that really means is we're going to take a look at what the graph of a quadratic looks like and the information that you can pull out of the equations related to the graph. And the reason why that's important is because the more comfortable you are with what a quadratic looks like, kind of that deeper insight you're going to get into its behavior, okay? And what its properties will be algebraically even. Okay, so really what we're trying to do is give you an insight into what these functions behave like. You already know what a linear function looks like and how it behaves, okay, from a previous course here. Now quadratic functions, now it says here contain a degree of 2. Actually they are degree 2, okay, which means at some point they're going to contain this x squared. Now, and the reason why it's x squared is because the graph is going to be a parabola and it's going to open either up or down. If it was the y squared, the parabola would go horizontally. But in this particular course here, we are specifically focused on functions, and so we're not going to look at parabolas that go sideways here. You could see that in another course. There's usually 3 different ways we're going to write the parabolas, specifically where the a coordinate is equal to 0. Okay, our different parameters here are significant, but we need to make sure that a is not equal to 0. And then there's a neat little question here: what would happen if a is 0? And we'll talk about that as we go through this. So let me maybe zoom in just a little bit here. So first of all, before we even get to the functions here, if a is positive, the graph is going to open up, and if a is negative, it's going to open down. We're going to talk about that a little bit more later on here, but yeah, this is going to correspond to a positive a value. This will correspond to a negative a value. So even right away, before we talk about anything else, see, you already have some knowledge as to what that function looks like. Now this is standard form here. This y equals ax squared plus bx plus c is what we call standard form, okay? This is probably not the most useful one to work with when you're trying to graph a quadratic. The 2 big pieces of information you can pull out of this is you'll know which direction it opens by looking at the a value. You'll know whether it opens up or down. And the c value is going to end up being the y-intercept, and that makes total sense here because remember, the y-intercept occurs when the x-coordinate is 0. And if the x-coordinate is 0, that means the ax squared and the bx are going to disappear, and you're just going to be left with y equals c. So there it is. So that's the y-intercept. But beyond that, right off the bat, that doesn't actually give us a lot that we can use to graph. It does have some interesting algebraic properties, but it's not quite so useful for us when we're trying to graph the quadratic. Another version of this is the factored form. Okay, and again, there's our a right up front here, but then we have this written in factored form: x minus m, x minus n. And in this particular case here, m and n are both the roots of the equation, and what that ends up being graphically are the x-intercepts. So from here, I can tell you which way it opens, and I can also tell you what the x-intercepts are. Now that's actually fairly useful for getting a pretty good sketch of the graph. Now it's not perfect yet because you don't know how far up or down the curve goes. And what I mean by that is, so here's your x-intercepts here. I mean, does the graph go like this? Does it go like this? It's actually the a value that helps you determine that, but it's not quite as obvious how that should work. The last form is called the vertex form, and this is actually, in terms of graphing, it's probably the most useful one that we'll work with here. You've got your a there, and the reason why this is so useful to us is because the h and the k value are significant. They form what's called the vertex of the parabola here, okay? And that ends up being the maximum or the minimum point of the graph, okay? That's our vertex. And you can probably imagine we're going to talk a little bit more about that because that particular point here, that vertex, that's a significant point on these parabolas here. So there you go. This is what the shape of the parabola looks like when it opens up or down. These are quadratic functions right here. Okay, notice this is just written, it's still a degree 2 even though there's no linear term here. Sometimes the absence of the linear term, you get so used to working with the 3 terms that sometimes the absence of that linear term throws people off a little bit, but that's still quadratic. This one's in vertex form, this one is in factored form, and this one is in standard form. Now before we talk about this one here, let's go back and talk about what does happen if we let a equal 0 here. Well, if a equals 0 in standard form, that means the ax squared term disappears. Now this is no longer quadratic. The highest degree here is 1. This is linear. Okay? If the a is equal to 0 here, well, notice that everything's being multiplied through here. So if a equals 0, everything equals 0. This whole thing actually just collapses to y equals 0. So everything disappears here. And in this case right here, because a is multiplied by this particular term here, if I let a equals 0, this term disappears, and all you're left with here is y equals k, which is another line. It's just going to be a horizontal line. Now, let's come down a little further here. These ones here are not quadratic. Okay, and please bear that in mind when you're working through these questions here and you're writing out quadratics. For example, if I had a student write this out, and I know what they're getting at, they intended to put a square here, but if you don't put a square there, you actually have said something very different than what you intended. Okay, I, like your teacher, would probably recognize that you intended to put the square there, but you didn't. And that still makes it wrong, okay? This one right here is also not quadratic. Even though there is a square there, that square root actually cancels that out. And this goes actually back to this form. These two are sort of equivalent forms there in terms of what's going on there. And here, even though there is a quadratic there, okay, even though there is that x squared there, because this is 1 over, this one behaves a lot more, well, very differently, let's say. Okay, the fact that the x is in the denominator is actually kind of this overriding property of that particular function, and that causes some pretty drastic changes. We would no longer consider that just to be quadratic. Now, before we move on and talk about like the different aspects of the graph and whatnot, let's just talk about this as our reference parabola. The most basic parabola that we can come up with here is this y equals x squared, and this is what it looks like. Okay, let me zoom in a little bit more here. Here's what your quadratic looks like, y equals x squared. Now notice it's got this minimum value of 0, and what I mean by that, it's the y coordinate I'm talking about, okay, when x is equal to 0. So when x is equal to 0, I get a y value of 0, and it's the minimum value. This is now my vertex, okay, that's what we call that particular point here is going to be 0, 0. Another thing that I want you to notice here is that starting on the vertex here, when we're dealing with y equals x squared, now maybe write this over here, y equals x squared. When we're looking at y equals x squared, when I take a horizontal step of 1 unit to the right or the left, doesn't really matter, to get back up onto the parabola, I have to go 1 unit up. So from here, it's 1 unit over, 1 unit up, 1 unit over, 1 unit up. That distance right there that you have to go up, this is your a value, and in this particular case, for the most basic parabola, that's going to be 1. So if you put a 2 there, if this was y equals 2x squared, you would go 1 over, and then you'd have to go 2 up to get back to the parabola. And what that does effectively is it narrows the parabola. And we'll talk about that more later on. I just want you to be aware of that in this particular basic parabola, that's what I'm looking for. When the a value is 1, starting at the vertex, if I take a horizontal step 1 over, I got to go a vertical step 1 up to get back onto the parabola. I had noticed, by the way, that the parabola is symmetric about that line that goes down the center of the graph here. It's like its own mirror image through the y-axis. And again, that's another thing that we're going to talk about in just a few minutes here in a little bit more detail. But there you go. So I hope this kind of sets you off here. Now let's take a look at some more specific details of the parabola. Okay, so now we're going to take a look specifically at some of the characteristics of the graphs of the quadratic functions here. And to start off with, as I had kind of hinted at here, the vertex takes center stage here. So the vertex is the turning point or the bending point of the graph, okay? So bearing in mind that we always read left to right, okay? I know that when we look at graphs, you tend to look at them as kind of one object here, but when you scan the graph here, you should be scanning left to right. And when you do that, as you follow along the points here, your eye should go down, hit a minimum point, and go back up. That minimum point, that's your vertex. Or if I'm scanning left to right in a graph like this that opens down, my eye goes up, up, up to a maximum and then drops back down here. Okay, these are your vertices right here, these maximum or minimum points here. And anytime that we ask you to identify a vertex, please write them as a point. Write them with coordinates here. So for example, let's say that this was the point here, let's say 1, 2, 3, 4. So the vertex here would be where the y-coordinate here is -4. You would write it not like that. That's just a list of numbers. Please, please don't do that. Please put parentheses around that to identify that that is a point. So now let's take a look at this one down here. So notice in this case right here, and it might be a little hard to tell, but I'll zoom in a little bit here. Notice in this case we've got the quadratic y equals x squared minus 4x plus 5. Now this is in standard form. Like I said, it doesn't give you a ton of information, but I do know that it opens up because the a value is positive. And remember that that c value there corresponds to the y-intercept. So in this case, you're given the vertex. The vertex is this value of 2, 1 here. So 2, 1, that's the turning point of the graph. That's the minimum. The minimum value here is going to be 1, okay, because that's the y-coordinate. The y-coordinate is the dependent variable. That's the one that, like, I don't know what you're getting for y. I choose the x values, and I'm always interested and curious as to, like, in my little experiment here, when I plug in a certain x value, what do I get as a y value? So what's special about that particular y value is it's the lowest one on the graph, okay, and that occurs when x is equal to 2. Now, with that information in mind here, let's take a quick look at this. If I've got a parabola that's y equals -x squared minus 5x minus 5, and I know that the vertex here is -3, 4, well, because of the negative right there in front of the x squared, I know that this is going to open down. Okay. -3, 4 means that I know that my y-axis is going to be over here to the right of the vertex. I know that my x-axis is going to be somewhere in there. So this is going to be, now my scale is way off. 1, 2, 3, 1, 2, 3, 4. There it is. And I know that from this right here, because it's in standard form, I know that my y-intercept here is going to be -5. So right there would be -5. And so with a little bit of information and kind of fiddling with my scale there, I can draw the parabola. But anyway, for this little section right here, the whole point here was that this is the vertex, it's the turning point of the graph. So in this particular case here, this graph has a maximum value of +4 when the x value is -3. Okay, of all of the values that I get for y, as I plug in all of my different x values, that is an interesting one because it is the highest or the largest y value that I get. Okay, now we're going to look at something called the axis of symmetry. Okay, and I had mentioned this before, that when you draw a parabola, particularly with where I mentioned it was with the original parabola, the y equals x squared, the y-axis there just kind of cuts it right in half. Well, it turns out every parabola, no matter where it's located, is going to have a line that cuts it in half right down the middle, so it's symmetric on either side. Now, because we're talking about quadratic functions here, for us, that's going to be a vertical line that divides the graph in half. And this vertical line passes through the vertex. Now, I want to draw your attention to a word here. Make sure that everybody sees this, because there's such a common mistake that gets made here, and it's so easy to avoid if people would just be a little bit more diligent to look into this. This is a line, okay? It's a line. It's a vertical line. And if you're going to identify a line, you need to have an equation for a line, okay? You need to have some sort of equation set up for a line. So I can't, for example, just give the number 2 and expect that that makes sense as an axis of symmetry. The number 2 is not a line, it's just a number, okay? You'll see what I mean here in just a moment here. We're going to go through and do an example. So the axis of symmetry is x is equal to h, okay? That right there, that is the x-coordinate of the vertex. So I'm going to let x equal the x-coordinate of the vertex, h. Or you could write it as x minus h equals 0. These are, you would have looked at these two forms of the equation of a line in a previous course. Okay? The axis of symmetry and the x-coordinates of the vertex pass exactly between the x-intercepts and can be found using the average of the x-intercepts here. So this is kind of an interesting little property here. This is so useful. And it's just, quite honestly, this is just about being clever. The axis of symmetry cuts the graph in half. Okay, so let's say that you know, so here's your parabola right here. There's your y-axis, there's your x-axis. Okay, your parabola does this. Okay, here's your m, here's your n, those are your x-intercepts there. We know that the axis of symmetry goes right smack dab down the middle of the parabola. But because of how the parabola is oriented here, we know that that means that it has to go exactly halfway in between m and n. So the x value here, if you want to figure out what number is right exactly halfway in between, well, it's just the average of those two. That's a very clever way of getting the x value of the vertex. But more directly, that would then be the equation of the axis of symmetry if you knew the roots. Really cool little relationship here. Love that. Okay, so here, take a look. This is kind of just a regular old parabola here. It opens up, goes through the vertex. The vertex is at 0, 0 here. Your axis of symmetry. Now, what happens to a lot of people, they get in kind of a rush here, and this is what they'll do here. You'll be asked, what is the axis of symmetry? Little colon there, and really quickly people look at this and go, oh, 0, done. Move on to the next question. That's wrong. That's not an axis of symmetry. It can't be an axis of symmetry. That's just a number. An axis of symmetry must be a line. So it's got to be, in this case, x equals 0. And if that sounds like we're being picky, yes, because we are being picky. This is a notation thing. You're saying something very wrong. Even though I know what you're intending, you're saying it wrong. And so part of mathematics here is this communication piece. Okay, if you're not being clear with your communication, then I don't know if you understand the concept you're trying to communicate. If you keep putting a 0 there, then I don't know that you actually understand what it is you're trying to communicate. I have a sense of what you intended, but if you keep doing that after a while, it looks like you don't know what it is we're asking you to do. So please be clear with your notation so that there can be no confusion about whether or not you understand the concept. So here, let's take a look at this one real quick. So notice here that the vertex is the point, you probably can't see that all that clearly, but it's the point 3, 1. Okay, which again means that as I look at all of the y-coordinates on this graph, this is an interesting one because y equals 1, y going to 1, that is the lowest value of y on this graph. That occurs where x is equal to 3. And right there, that becomes my axis of symmetry. Okay, my axis of symmetry, and I know it's written up here, but I'm going to write it again a little bit bigger, is going to be not 3, but x equal to 3. Or if you want to write it in a slightly different form, x minus 3 is equal to 0. If you just bring the 3 over to the left-hand side of the equation, that looks good too. Okay, so these next two little pieces here we're going to look at together. And I've already been really trying to set the stage for this so that when we get to this specific point here, it's this ground that we've already gone over. The minimum value, okay, is referring specifically to the y value of the vertex. Because remember what this is, what it is that we're doing here. When we're working with functions, it's like we're doing a little experiment, okay? The manipulated variable is the x-coordinate, and the responding variable is the y-coordinate. And so what we do is we alter the x values, and we keep looking in curiosity to see what we get. Sorry, did I say x values? We alter the x values because we're curious as to what the responding y value is going to be. Okay? So we don't know what the y value is. It's a kind of a mystery. So as we plug these things in, and we always start plugging values in for x from negative infinity, and we swoop over to positive infinity, And then what we notice the y-coordinates, and like for example in this graph right now, because this parabola opens up, my y-coordinates drop down, drop down, drop down, but then they hit this minimum value of -4. This is the smallest that they get, and then the y values go up again. That is an interesting value in this particular function. Okay, that is significant. And so when I ask you what is the minimum value, all I want is the y-coordinate of the vertex. That's it. And so in this particular case here, you could get away with doing this. You could say the min value here, colon, and just put -4. Now, don't put y equals -4, because that's the equation of a line, okay? And that's not what I'm asking for. And I know that sounds picky, but we got to make sure that we clean up everybody's notation here. My minimum value is just the number -4. And up here, remember that in order to have a minimum value, okay, in order to have a minimum value, your range has to be greater than or equal to that minimum value, okay? So we choose some sort of value, then all of the values for y are above that. Now compare that to your maximum value. This is basically the exact opposite. So the parabola has to open down, which means the a value is negative, okay? So in this case here, without even knowing specifically what the a value is, I know that it's negative, okay? Now, in this particular graph here, what I'm looking for here is what that maximum value of y is, okay? Because the y values go up, 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 up. Oh, it hits a maximum value of 1 in this case. And then it drops back down again. So that is an interesting number, okay? In this little experiment that I do here, I don't get any values as a result of doing the quadratic or applying the quadratic. I don't get any values that are larger than 1. That's interesting. Anyway, so I hope that makes sense. So I hope you're seeing the significance here. The x-coordinate of the vertex, in fact, I'll write this over here. When you've got the vertex, okay, you've got this vertex h comma k here. The h is going to be related to your axis of symmetry. Okay, that's just going to be x is equal to h. The k is going to be your max or your min value depending on what the value of a is, whether this graph opens up or down. So you're grabbing a bunch of information just by knowing what the vertex is and the direction that the graph opens. Okay, so the last property that we're going to look at right now will be the x and y intercepts. I mean, there are other things that we're going to look at here, but we're just going to briefly mention this here. Remember that to find the y-intercept, you make the x equal to 0 in the equation and solve for y, okay? This is basically just the process of evaluation, okay? So, for example, when I gave you, let's say I gave you the equation like this. Let's say it's 3x minus 2x plus 4, and I want to know what the y-intercept here. Sometimes there's a bit of confusion here, particularly when there's two x's that show up here, but when I set x equal to 0, I mean every x in here is going to go to 0. So it's going to be 3 times 0 minus 2 times 0 plus 4, and then you just evaluate. Remember, order of operations tells you what to do, what's inside the brackets first. So 0 minus 2 is -2, 0 plus 4 is 4. And I'm just going to multiply across here. 3 times -2 is going to be -6 times 4 is -24. So y equals -24. Okay. So that's when I plug that in, this is what I'm getting for my y value. So therefore my y-intercept is going to be -24. Normally I wouldn't write, even though I used this line of reasoning to get the y-intercept, I wouldn't write the y-intercept as y equals -24. I just write it as y-intercept colon -24. Because this is the equation of a line. That's not what I intend, even though I'm using this idea to get the y-intercept. Okay? So the y-intercept is pretty straightforward. You just plug it in and away you go. Now, to get the x-intercepts here, you make y equal to 0 and then you solve for x. Okay, that, everybody, that is not always easy. In fact, sometimes that can be quite difficult. Okay, so let me give you an example here just to show you what we mean by that. Now let's just sort of straightforward on it here. Let's say it's y equals x squared, let's say plus 5x plus 6. As soon as I set y equal to 0, x squared, 0 equals x squared plus 5x plus 6, look at what I'm left with. Oh, and by the way, this has nothing to do with this graph. It has nothing to do with that graph. This is just me going off on a little bit of a tangent. As soon as I do this, you've done this before. This is solving a quadratic equation. So how do you solve a quadratic equation? Well, you could factor, and in this case, this does factor quite nicely. But remember that sometimes it doesn't factor nicely. Sometimes you will look at it forever and not see those factors, in which case you're going to need the quadratic formula. So this is ground that we've already gone over in preparation for this. But finding the x-intercept here can be very difficult, can be very challenging. Finding the y-intercept shouldn't be a problem at all, ever. Because it's just order of operations like you've been doing for years. Finding the x-intercepts involves creating an equation that requires solving, and that can be difficult. Now, just because I feel obliged to do this now, we will finish this. So this is x plus 2, x plus 3. I'm just going to kind of guess and check. So either x plus 2 is equal to 0 or x plus 3 is equal to 0. And when I solve here, I will get this and this. And so my x-intercepts would be -2 and -3. And there you go. And again, that has nothing to do with this graph right here. This is just illustrating where those are on the graph. Okay, so now what we're going to do is we're going to go through just a couple of examples where we're looking at a parabola, a quadratic function, and we're grabbing the pieces, the different characteristics of the parabola and putting them off from the side. They're just being deliberate about finding them. Now in this first case here, we're going to take a look at y equals x squared minus 6x plus 5. And what I want to do here is I want to build a table of values. Now I know that building a table of values can be tedious. So we're going to use the calculator here. Now we're not going to use the calculator specifically to graph, although I could easily do that. Instead I'm going to do this. I'm going to go to y equals, just like what if I was going to graph here, and I'm going to enter my x squared minus 6x plus 5. Okay? But instead of going graph and seeing what the parabola looks like, I'm going to press second graph, which takes me to my table of values. I'll zoom in a little bit here. And now the table of values on my calculator starts at 0, but I can adjust that by just pressing up one arrow, and I get all my y coordinates even down to 7 here, like on my chart here. So at -1, I see that it's 12. 0 is 5. 1 is 0. 2, -3. 3, -4. 4 is -3. So all of a sudden it's bounced back up again. Okay, our y coordinates are starting to increase. 5 is going to be 0. 6 gives us a y coordinate of 5. And 7 gives us a y coordinate of 12. Okay, now I've got now my list of my y coordinates here. Now I'm going to plot this. And I feel fairly confident right now that this is going to be my vertex right here, because it's not only the lowest value on the lowest y coordinate here on the graph, which is important, okay, because my vertex will be the lowest or the highest point on the graph. But more importantly, notice that I'm getting the same values on either side, equidistant from 3 here, which means that this is the center. Okay, this is exactly halfway between the 3 here is exactly halfway between the 2 and the 4. I'm getting the same y value. So that indicates to me that this right here has got to be the vertex. Anyway, so now let's take a look at our points here. It's going to be -1, 12, right there. And then I also knew that it was going to be 7, 12. Okay, there's some symmetry here. So I can drop those 2 points right away here. 0, 5, kind of a big drop there. And then it's going to be 6, 5. Okay, 1, 0. And so that's going to be 5, 0 right there. Because notice my scale is going up by 2s. If you hadn't already seen that. What do we got here? 2, -3. It's going to be right here. 4, -3. And then 3, -4. And so those are all the points that I'm getting here. And now if I try to connect this, this is not always super easy to do and make this look good. So you can see I'm kind of struggling a little bit. Well, that's not too bad. I've done worse. Okay, so there's my parabola. So now let's come over here and take a look at the different pieces here. So my vertex, I'd already kind of narrowed it down that that's got to be the point 3, negative 4. And notice I got to put parentheses around that to make that work. Now, as soon as I know that, I know the axis of symmetry. Now, it's not going to be 3. Remember, it's x equals 3. Okay, x has got to equal the x coordinate of the vertex here. This particular function here is going to have a minimum value, and the minimum value is going to be negative 4, because both of these come from the vertex. Now, my x-intercept, I can get that from my graph, or I can even just look at my chart here. My x-interceptors are going to occur where the y-coordinate is 0. And so that's going to be 1 and 5. So I'm expecting the numbers 1 and 5 for my x-intercepts. The y-intercept is also, I can easily read that off my graph, or I could look at my chart here. The y-intercept is going to occur where the x-coordinate is 0. And I get 5 here, so the y-intercept here is going to be 5. The domain for this function here, and if I just think about this, remember that the domain is the set of all acceptable, allowable values for the independent variable, so for x. And if I take a quick look at what I'm doing to the x value with my function here, I'm squaring it and then subtracting 6 times x and adding 5. Now, is there any number, is there any real number that you couldn't do that to, that you couldn't square, that you couldn't then subtract 6 times that value and then add 5? Well, the answer is no. And you kind of get that indication from this. This is going to extend in both directions here, infinitely here. So my domain is going to be that x is an element of the real numbers. Okay, x is in the entire set of real numbers, everything. My range is a little bit different. And remember that my range is always of interest to me because it's the result, in a sense, of my experiment here. So as I read this graph through left to right here, I see my y-coordinates start way, way up high, and then they drop down, and they get to this value right here, and then they start to turn around. That is an interesting number. It's the lowest value that my y-coordinates get to. It's negative 4. So my range here is going to be all values greater than or equal to negative 4. And there we go. So now we're going to do the same sort of thing again, but this time without having to go and plot it. Now we're going to take a look at what the plots look like and just grab the information off of the plots. Okay, in this question, we're going to fill in the blanks for each of the following diagrams. And so we got a couple here. And so what I'm going to do is I'm just going to look at my diagram here and grab the information that they're asking for. So now remember, the vertex is that maximum or minimum point, that turning point on the graph, and that appears to be right there. And that looks to be the point negative 3, 0. And remember, you need to put parentheses around that because it is an actual point you're looking for. Without the parentheses, it's just a list of numbers. Once you know that, we can immediately jump down to these two here. I know that my axis of symmetry will be x equals negative 3. And because this one opens up, I know that's got a min value, and the min value here is going to be 0. Both of those are linked to the vertex. My x-intercepts, where does it hit the x-axis? Well, actually, it's just right there at negative 3. It just has this one x-intercept. Okay? That's okay, because the vertex is right on the x-axis. That's fine. That's what that means. Now, normally, in most of the cases that we've looked at, or that you will look at, you're going to see 2 x-intercepts because the graph will cross the x-axis twice. But here it just hits it once. It doesn't even have to hit the x-axis. That's fine. The y-intercept is going to be where the graph crosses the y-axis, and that's a little bit harder to read here, but it looks to be, assuming that I'm not trying to be tricked with some sort of decimal number, that looks to me to be about 9. My domain, and you're going to see this is going to happen quite a bit here. The domain is all reals. Okay, the little arrows there imply that this extends infinitely left and right. And my range, as I scan this thing left to right, my y-coordinates start high, they drop down, and we get to a minimum value here at 0 and then go back up. So all of the y-coordinates on my graph are going to be greater than or equal to 0. Okay, let's take a look at another one. This time here, my graph is opening down. So here I've got my maximum point here, and when I take a look at that, it looks to be the point 3, 2. So that's my vertex, 3, 2. The axis of symmetry will then, just by default, be x equals 3. And in this case here, I've got a maximum value, and the maximum value the graph reaches up to is 2. My x-intercepts, where the graph crosses the x-axis, are going to be 2 and 4. I just list those. Now, notice without parentheses, because as soon as you put parentheses here, that's the point 2, 4. And that's not the x-intercept. The x-intercepts are the values 2 and 4 here, so don't put parentheses there. The domain, and you're starting to see a pattern here. The arrow indicates that, the arrows indicate that it goes infinitely left and right and down here, so this is going to be all reals. But my range, my graph apparently starts way, way down low, and then it swings up, hits this maximum value of 2, okay, and then drops back down again. So that's an interesting number. That's the boundary point up here. The graph kind of doesn't get beyond that. So all of the y-coordinates for this graph are going to be less than or equal to this maximum value of 2. Hope that makes sense. Okay, now before we take a look at just a couple more examples where we're doing basically the same thing, I want to talk really quickly about how you might use the graphing calculator to help you do this. So when you press second trace, okay, that opens up what we call your calc menu. Okay, and what that is really it's a menu of items that giving us functions that I can apply to a graph. So I can use these tools here to help me analyze graphs that I've plotted. And here's a list of things that we do here. Value lets you find the y-intercept if you let x equal 0. Now it can let you find any y-coordinate if you know the x-coordinate. But in particular, what we're interested in here is finding the y-intercept. So you would use value for that. If you want to know the x-intercepts, you'd use the 0 function. Okay. And then basically the calculator has you look to the left and look to the right of a certain value, and then it'll find the x-intercept as long as it's in between the two little boundary points that you set up. We'll do an example of that. Both minimum and maximum here are used to find, now in this particular context it's going to be the vertex, but what you're going to do is you're going to use it to find the largest point or the smallest point, and basically what I mean by that is the highest point on the graph or the lowest point, the maximum or the minimum, on the grid there. Then, make sure we're taking a look at the window here. When you have your calculator in basic default settings here, its x min and max are going to be negative 10 and 10, and it goes up by 1. The y min and max are negative 10 and 10, and again, it goes up by 1. Now, what that means is, on your calculator, when you look at the screen, left and right, this right here is your x min, this right here is your x max. And when it says x scale, what that refers to is all the little tick marks, how big the tick marks are. Okay? When you look at your y min and max right here, this is your y min, so it's the lowest value on the graph. This is your y max, that's your highest value on the graph. Okay? So by adjusting those, you can expand that, make it bigger, make it smaller, focus in on a certain part of the graph, or pull it back so you can see more and more of the graph. It's something you need to be familiar with, because what we can do on an exam, for example, to make things a little bit more difficult is have you graph a parabola, but maybe have that vertex be off the screen, somewhere over here, for example. So we'd have you graph the parabola and it looks something like this. All you see is this line right here. You don't see this part, and so you have to expand that out a little bit. Make the x max bigger, the y max bigger. Anyway, let's take a look at some examples where we got to use the calculator to find those different characteristics of the graph. Okay, so for our first example here, we're going to enter y equals x squared plus 2x minus 3. So here we go. So y equals x squared plus 2x minus 3. This time I'm going to graph that. And my window settings are already at the default settings, so I'm going negative 10 to 10, negative 10 to 10. Okay, so here we go. So it's a parabola that opens up. Now, I don't really have enough for me to give myself a good sketch here. I actually need to find some of the details. I mean, granted, I can kind of intuit where some of the things are here, but I want to do better than that. So I'm going to press second trace. And the first thing I'm going to look for here is the vertex. That's the first thing I'm looking for here. Now, I know that my parabola opened up, so the vertex is going to be a minimum. So I'm going to choose the minimum feature, and it asks me for a left bound. Well, Okay, here's my vertex right here, and my cursor is blinking over here. So what I'm going to do first of all is move my cursor so it's to the left of the vertex. I'm going to press enter, and I get this little triangle and a line here. Now it's asking for a right bound, so I'm going to move my cursor beyond the vertex. In fact, I'll move it way over here. Just as long as it's to the right. Press enter. And so now it's asking for a guess here. Now, I wouldn't worry so much about the guess. You can press enter to get past that. The guess is really just an opportunity for you to help the calculator get to the answer faster. But you're not going to notice much of a time delay anyway. Press enter, and I get right away here that the vertex is the point -1, -4. Okay, so here we go. I can go to the vertex here, -1, -4, and that's a point. I then know that the axis of symmetry is x equals -1. I also know, because this thing opened up, that it's got a minimum value of -4. Okay. All right, well now I need to go back to the calculator here. Okay, actually, sorry, I should do this. I know that the vertex here was -1, -4, so it's going to be -1, 1, 2, 3, 4. It's going to be right there. Now I got to find the x-intercepts. Okay, so to get the x-intercepts, I press second trace again, and this time I'm going to use the 0 feature. So I want to find, let's say, this x-intercept here first. So the calculator says left bound. So what I got to do is I'm going to use my left and right arrow keys. I'm going to move the cursor basically so it's on top of the x-intercept, and then I'm going to press the left key a few times, just to make sure I am to the left of it. And please, I have done this with a lot of students here. Please don't confuse up and down with left and right. Okay, really common thing to do here is to think that when I say left and right, I'm actually meaning up and down here, because it's going to change once you get over here. So press enter, it draws the little boundary line there. I'm going to go back to the x-intercept, because the calculator is now looking for a right bound, so I press the right arrow a few times, and it puts another line there. What we need for this to work is we need the x-intercept to be between these two lines. Okay? Often people get an error that pops up with this, and the error is no sign change. It's no sign change because you put your left and right up here. The x-intercept wasn't in between your left and your right. If I now press enter just to give it a guess here, because it's asking me for a guess, it gives me the x-intercept here at -3. Okay, that point right there, -3, 0. So my x-intercept here, I'll zoom out a little bit. Whoops, wrong way. My first one here is going to be -3. So -1, 2, 3, there it is. Okay, now let's find the other one. So second trace 0, and this time I'm going to move my cursor to the other x-intercept. So I move it so it's basically on top, and then once again I go to the left a few times, and notice that this time when I went to the left it actually dropped it below. Okay, but the point is it's to the left. It doesn't really matter if it's above or below the x-intercept. What matters is that it's to the left. Then you go back to the x-intercept and keep going a little while longer to make sure you're to the right. Okay, the x-intercept should be between those two boundary points. Press enter to get past the guess, and I get an x-intercept of 1. So my other one here is 1, and there we go. Whoops, sorry, you didn't see that. So there's the 3 points I have this far. Now, I want to find the y-intercept. I'll use the calculator to do this, even though I really don't need to. I can tell from the equation here, but I will use the calculator. I'll press second trace. This time I'll use value. And I know that the x value at the y-intercept is 0. And this one tells me that the y-intercept here is -3. And so there it is right there, -3. Now, because of the axis of symmetry going right down the middle like this, I know that there should be a point also over here, because it's symmetric. And now I can graph this parabola. It's not perfect, but you get the idea. My domain is going to be an element of the reals, always seems to be, and it will, unless you've got a word problem here that's a little different. My range is going to be, because it's got this minimum value here, this low value, it's going to be y is greater than or equal to, and that minimum value there was -4. So y is greater than or equal to -4. Okay, let's do one more. This time it's negative x squared plus 5x plus 14. We'll clear that one out here. So negative x squared plus 5x plus 14 graph. Oh, look at that. The vertex went off the screen. Somewhere up here is my vertex. So I'm going to need to adjust my window settings a little bit here. The issue is my Y max. The top of my screen isn't high enough, so I'm going to make that a little bit bigger. Now, at this point, I don't know what it's supposed to be, so I'm just going to guess. Let's guess 20. I don't know. Does 20 work when I press graph now? Oh, 20 just barely works. So I tell you, oh, it doesn't work. I shouldn't say barely works. It doesn't work. It's really close, though. So let's change that to 25. 25 should be fine. When I press graph, there we go. There we go. So there's my quadratic here. So now I'm going to go into my graph and I'm going to look for that vertex. And this time it's going to be a maximum because the parabola opens down. And remember, my vertex is right here. So I want to make sure that my cursor is first of all to the left of it. Press enter. It draws that little boundary. Move past the vertex so that I'm to the right of it. Press enter. So as long as the vertex is in between those two right now, if I press enter to get past the guess, it'll take me there. Let's take a quick look at that. And I've got this weird sort of a number, 2.49999. I suspect that's supposed to be 2.5 and 20.25. So 20 and a quarter and 2.5. So my vertex, now I would probably leave it as the decimals here, 2.5 comma 20.25. I know that my axis of symmetry is therefore x equals 2.5. And I know that I've got a maximum value of 20.25. Okay? Now, the next thing I want to look for here are my x-intercepts. So I'll go second, trace. This time, what time we're using the 0 function. So I'll find the one on the left first. So I'll move my cursor way down. It's on top of it, basically, not 100%. I can't quite trust what the calculator is telling me right now because I'm not bang on top of it. The y coordinate isn't 0 quite yet. So I'll move a few to the left, press enter, go past it, move a few to the right, and as long as that x-intercept is in between those two lines, if I press enter now, one more time, I get negative 2. So one of my x-intercepts here is negative 2. And now I got to do that again. Whoops, sorry. Now I got to do that again and find the x-intercept way over here. So I move my cursor again till I'm basically on top of it, and then I'm going to come back a little bit, make sure I'm to the left, press enter, go past it, make sure I'm to the right of it, press enter, and again, as long as it's in between, when I press enter a third time, it'll give me the x-intercept there of 7. Okay? To get the y-intercept, remember I go second, trace, this time I go value. It's asking me what x equals, I'm going to say 0, and I get that y is equal to 14. So my y-intercept here is 14. My domain will be x is an element of the reals, and my range, because it opens down, will be less than or equal to that maximum value that it got to, which was 20.25. Now, I've got this grid here. I'm going to put my stuff on the grid here. I know that my x-intercepts are going to be negative 2 and 7. 1, 2, 3, 4, 5, 6, 7. That's easy. My y-intercept was 14, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's no scale on there, so I got to do it like that. And then my vertex is 2.5, 20.25. Okay, oh boy, here we go. So 14, 15, 16, 17, 18, 19, 20. So it's just a little bit higher than that. Then it's 1, 2.5. So it's going to be right there. Okay, ish. My axis of symmetry comes right down the center here. So I know that this point is going to be mirrored over there. And then I graph the parabola like that. Oh, I'm not as pleased with that side as I was with the other side. Okay, anyway, and there you go. That's what your parabola should look like. So I hope this gives you some confidence when you're analyzing parabolas.